All right, continuing on our accumulation functions lesson. So here's another bit of a review here when we're talking about total change or net change. That if we take a, like this is based on the fundamental theorem of calculus, of course. So we're taking a definite integral from a to b of f of x. Well, I can replace f of x with like the derivative of the antiderivative. And we usually write the antiderivative as a capital F of x. So that's what's happening in that. The next equation there is the definite integral from a to b of capital F of prime of x. And that shows us that that's a rate of change. So now we're taking the definite integral of some sort of rate of change, and it's equal to the net change in whatever that quantity is that we're measuring. Now, one of the things that we sometimes do is that we take this f of a, which is the initial value, and we add it to the other side of the equation. So it looks like this. So we have a final amount, this big F of b is equal to some initial amount, big F of a, plus, and then we have our accumulated rate of change from that definite integral. And we've seen this play out on a couple of our questions so far, and it's definitely going to play out in this zoo question that we have in example 2, which is also calculator active. The rate at which people enter the Naples Zoo on a given day is modeled by the function e, defined by, and then we have this natural log function here. The rate at which people leave the zoo on the same day is modeled by the function L, defined by, and then we have what looks like an arctangent function. Both e of t and L of t are measured in people per hour, and time t is measured in hours after 8 a.m. These functions are valid between 0 and 12, the hours during which the zoo is open. At time t equals 0, there's no one in the zoo, obviously. They're not counting all the people like the zookeepers, the lion tamers, and all of that. Right? They have lion tamers at a zoo. Or is that a circus? Anyway, yeah, so they're not counting those, just patrons, customers. So let's look at each one of these parts. Part A, how many people have entered the zoo by 12 p.m.? So 12 p.m., I guess that'd be 4 hours after they open. Part B, 20% of those people who leave the zoo receive a special discount ticket for a return trip to the zoo. How many people have received a discount ticket by 5 p.m.? Interesting, all right? Let n of t equal the definite integral from 0 to t of e of x minus L of x dx. And so notice that we have one of these integral equations, and there's two different variables. The variable for the function is t, but inside the integral we have x. Those things need to be different. For 0 less than or equal to t, which is less than or equal to 12, find the value of n of 10 and explain the meaning of n of 10 in the context of this particular problem. Find n prime of 10 and explain the meaning of n prime of 10 in the context of the problem. And then finally, part D, at what time between 0 and 12 does the model predict the number of people in the zoo is at a maximum? Justify your answer. Closed interval test, candidates test, however you want to phrase it. So let's take a look. So of course, just for convenience, I copied down the equations. I know that I'm going to have to put these things into the calculator. And let's take a look at part A, maybe enlarge it by a little bit and then move this other stuff down. Maybe I should have done that too already. I don't know. Okay, how many people have entered the zoo by 12 p.m.? So, whoa, okay, that's Mr. LaBelle again. How many people have entered the zoo by 12 p.m.? I'm going to find the accumulation of this e function. The e function, let's make some sort of notes. This is entering the zoo, rate at which people enter zoo. And then L of t is the rate at which people exit or leave zoo. Okay, there we go. And so here we're just going to deal with this e of t function, and that's it. And by 12 p.m., starting at 8 a.m., this should be 4 hours. Okay, so our problem is going to be set up thusly. We want to write definite integral. We don't have an initial value. Our initial value is 0. There was nobody in the zoo. From 0 to 4 of our rate of change equation, which is E of t dt. And then it turns into a calculator problem. So pull up the calculator here, and I'm actually going to start a new document. And I'll go to a calculator screen, and then I'm going to add in a graph screen because that's where I'm going to type both of these equations in. So we've got 23 natural log, and inside the parentheses we've got t squared, so we'll make it x squared plus 3x plus 1. And while I'm at it, I might as well just add the next one into it. Let me double check to make sure that's typed in correctly. Okay, hit enter on that one. And then let's add another one. So I just hit the little plus sign up there in the top right-hand corner. And for f of 2, that'll be our L of t function. So 63 plus 50. Arctangent. To get arctangent, just hold your finger on tangent, and then it's the first one there. Arctangent of, inside the parentheses, we've got a fraction, x minus 6 divided by 2. So arrow down to double check. All that looks okay. Hit enter. All right, it's golden. And now we need to switch back to our calculator screen here. And then tap in the white space. The keyboard will pop up as it does. And then we will need a definite integral. And we said that was going from 0 up to 4 hours, I think. And then our functions are stored under the var menu. And then we're going to choose f1 of x. And then on the outside here, put an x. Enter. What? All right, that's pretty insane. So again, that's because this is a computer algebra system. It's giving us an exact answer. We just want the approximate one. So hold your finger on this, and then you can see the approximately equal sign right there. We got 203.068. Which we're going to say is about 203 people. That's not how you spell that word. Enter the zoo. By 12 p.m. All right, so that part I do believe is finished. Okay, and let's see. Part B, the discount part. People leaving the zoo. Okay, 20% of those people who leave the zoo receive a special discount for a return trip. And we want to know by 5 p.m. 5 p.m., let's see. Up to 12 was 4 hours. So this is going to be 4. And then another 5 hours, we're at t equals 9 hours, it looks like. Right, and this time what we're looking to examine is only the leaving function, which is the L of t. We don't have to consider people entering the zoo. So it's just the L of t part. And so we're going to do the same thing that we did on part A, just with new numbers, new functions. So from 0 to 9, the L of t dt, calculator time. And remember, we already stored that into the calculator. How handy. Definite integral button, 0, 9. And then inside here this time, under the var menu, we're going to choose F2. Put an x in there, put another x in there. Hold your finger on enter because we want to approximate it. So we've got 395.902. Okay, so this is the number of people leaving the zoo. But we want only 20% of this. So we're going to take 0.2 times 0.20 times 395.902, again, calculator. So just hit times 0.2, enter. I didn't have to approximate that one because I put a decimal in it, and then it automatically goes, oh, you want an approximation. So we're going 79,180. So we're going to say about 79 people receive this discount. I think it's EIV. Yeah, the discount. By 5 p.m. Have I been highlighting my answers? I don't think that I have. Okay, let's look at part C, shall we? Before this is essential. Get rid of this. Okay. Part C, enlarge. Done. Let n of t equal this accumulation function here between 0 and 12. We want to know what is n of 10. So let's go ahead and write something down for this. So n of 10 is equal to, boop, definite integral from 0 to 10, e of x minus L of x dx. All right, so let's examine the different parts of this. Here we have people entering the zoo, the rate, right? And then we have people exiting the zoo here on the L of t part. Out. So if we were just to plug in 10, the 10 is in hours. This is going to give us the accumulation of the difference between these. If I take in minus out, I should get the total number of people that are in the zoo at 10 hours after they open. Right, so now it's a calculator kind of question. And I can pull up a definite integral from 0 to 10. That's what it was. And inside here, we want an f of, so I need to pull up the vars menu, f, put an x, an arrow out of it, minus, we want the sub 2 one, put an x, and then an x right here. And remember, we want an approximation here. So we've got 273, 635, 635. So in my interpretation, I'm going to say approximately 274 people are in the zoo at 10 hours. Yeah, t equals 10 hours after 8 a.m. That should do it right there. All right, so next we want to know what is n prime of 10. So to find n prime of 10, we need to first find n prime. Let's write that part down first. So n of t, remember, was the definite integral from 0 to x, nope, t, e of x minus L of x. We want to take its derivative. And since taking a derivative of a definite integral, I just changed the variables. They're inverses of each other. Hey, get back on pencil. So this should be e of t minus L of t. And now I just want to stick my 10 in there. E of 10 minus L of 10. All right, calculator time once again. So there's no definite integral on this part. I just need to call up the functions. I want f of 10 minus, it wasn't, no, minus, there we go, f sub 2 of 10, and then let's approximate this one. Negative 0.6, no, negative 2, negative 6.228. Okay, this is a rate of change. So it is a rate of change. E of t and L of t were rates of change, remember, as a rate of coming in versus coming out. And since this number is negative, this means that the number of people in the zoo is decreasing at that particular time. So that's how we're going to phrase the answer to this, the interpretation. at t equals 10 hours after 8 a.m., the number of people, because that's what n of t is measuring, is number of people in the zoo, in the zoo is decreasing at a rate, this is a key word here, rate, because we took some sort of derivative here of, and I'm not going to put the negative sign in there because we said that we're decreasing, 6.228 people per hour. Yay. All right, highlight some stuff here. Bloop, decreasing, I don't know. That one, that should be good. All right, one last portion on this one. Part D. At what time t, between 0 and 12, does the model predict that the number of people in the zoo is at a maximum, and justify your answer? Looks like this kind of thing is common to a lot of these things, where we are taking a look at a maximum, and in order to find a maximum, we want the closed interval test. Hopefully, you know, something like the closed interval test appears on AP Calculus exam. Hey, look, I've got a new icon here, which is a laser pointer. Is it working? Oh, yeah, there it goes. Oh, look. Are you a cat? Here, chase it around. All right, anyway. Let's go back to the problem. In order to find a maximum, those things are going to occur at either endpoints, 0 and 12, or at critical points. To find our critical points, we need to take the equation that we have right here, take its derivative, which we've already done right here. Hey, you know what? I'm going to duplicate that and then just move that down. Perfect. Yay. All right, I can get rid of these check marks though. And then we're supposed to take our derivative and set it equal to 0 to find our critical numbers. There we go. And then, of course, we're going to do that part on the calculator. I think this was calculator active. Calculator. All right, pull up the calculator. We already have these functions stored in here. Let's go back to our window picker and choose the graph screen. And I'm going to change this up just a little bit. Let's go to plus sign, and let's actually subtract them, because that's how it is. It's formatted, and that's how we're supposed to find the zeros of that. So I'm going to go to vars f sub 1 of x minus f sub 2 of x. Hit enter on that one. And now my graphs are totally confusing, so I need to get rid of some of these. So the hamburger menu here, I'm going to go up to F1, and I'm going to tap the check mark and turn it off, and then do the same thing with F sub 2. Turn that one off because we don't need it. And now we have our two functions. And remember, this is only going from 0 to 12, which means we only have one number here. There's another one that's way over here. It looks like somewhere close to, I don't know, 16 or 17. So it's off. It's outside of our range. And by range, I, of course, mean domain. All right, and then we have one right smack in the middle. Let's find its value. So I hit the wrench, analyze graph. I'm going to choose a 0, and let's move this green line closer to it. Other one is already in the correct spot. And we've got a value here at 813. 8.13, and remember, just like we did before, oh yeah, I need to actually select it. I'm going to select this and then tap it one more time, and let's actually store that in as an A. Hit enter. Okay, so it overwrote the previous A that we did in the last problem, and that's totally fine. So I want to make note that we have ourselves a critical number here. So critical number is that x is equal to, and by x I mean t, is equal to 8.134, I think it was. Right, and then the rest of the closed interval test just looks like a t-chart. We've got t values. We've got n of t values. And our points are going to be 0 and our 8.134, and then finally our other endpoint of 12. Okay, so we know the answer to the first one. It's 0. There were no people in the park whenever it opened, except for the lion tamers. All right, and then for the next part, what we're going to do is straight up in the calculator, put, boop, window picker, go up to the calculator. And now remember, I have a new function in there. It's f of 3, or f sub 3, and f sub 3 already does the subtraction part for me, so I'm going to use that one. So pick the definite integral from 0 up to a. Inside here, I'm going to choose my variables and then do f sub 3. I can put the other ones in there if I wanted to, but this one takes care of it in one step. And then put an x, and then approximate it. We got 281, 117. Okay, and then we got one more to do, and that's at 12. So go back to the calculator one more time. I'll just copy and paste that. And then change that a up here. Maybe. Come on, change. To a 12. Approximate. Boop. 160, 905. 260, 905. All right, winner at our critical number. So let's just wrap it up here. The max number of people in the park. What is this mess? What is this mess? Is about, I'm going to round that to 281 people. At t equals 8.134 hours after 8 a.m. And then that wraps up that question. All right, I want to say this was the second example, so you may have one more. Yeah, it was the second one. Let's take a look here. Back at our worksheet. Okay, so our last one here involves this milk question. So one last time, take yourself about 15 minutes, see what you can do with it. Check your answers either with the answer key or with the last video coming up.